Here are the answers for the Section 4-7 Application Problems Homework Assignment. Page 143, number 1. Find 4 consecutive integers such that the sum of the squares of the first and fourth is 45. Let's follow the problem-solving plan that we've used before this year. First step, define variables. We're looking for 4 consecutive integers. So our first number we could call x. The next consecutive integer after that would be x plus 1. Our third consecutive integer would be x plus 2. And the fourth one would be x plus 3. The idea is that the word consecutive tells you that each number is one more than the previous number. Now let's reread to make an equation. The sum of the squares of the first, so that would be x squared plus, because the word sub means plus, and the fourth, so let's show the square of the fourth, is 45, so equals 45. This equation fits this statement. Now we want to solve this equation using techniques that we've learned. We know that when we have equations that have degree 2, that one technique is to factor the left side and on the right side have a 0. Let's try to create that format. In the process of doing that, we need to square this binomial so that our terms can be combined. Here's how you square a binomial. Take the first term and square it. Double the product of those two terms. That would make 6x. And then square the 3. Now let's combine like terms and get a 0 on the right. X squared plus x squared is 2x squared. Here's the 6x. And now let's subtract 45 from both sides. 9 subtract 45 is negative 36. And that's now equal to 0. Now let's factor the trinomial on the left side. All terms divide by 2. Here we have x squared plus 3x minus 18, and that's equal to 0. Now factor the trinomial in the parentheses using FOIL. We have x times x for our x squared, and we need two numbers that multiply to negative 18, and the two numbers we choose must add together to make positive 3. Let's go with positive 6 times negative 3. Now take each factor and set it equal to 0. So the x plus 6 could be equal to 0, or the x minus 3 could be equal to 0. And solve each of these. This is x equals negative 6, or x equals positive 3. Now we're not done. We need to check that result in the context of the original question. We're told to find 4 consecutive integers. If the first number was negative 6, then the next number is negative 5, the next one is negative 4, and the next one is negative 3. Or, if the first number was 3, then the next one is 4, then 5, then 6. So here are our 2 possible solutions to this problem. Number 3. If the length of one side of a square is increased by 1 inch, and the length of another side is decreased by 2 inches, a rectangle is formed, and we're given the area of the rectangle. Find the length of a side of the square. This problem discusses a square and a rectangle. So a good problem-solving strategy is to draw diagrams and label the sides with whatever information we can. I'm not trying to draw to scale. I just want to have a picture of a square and a rectangle to look at. The question asked, what is the length of a side of the square? That's what we need to choose a variable for. How about using x on the side of the square? Now it tells us how to create the rectangle. One side of the square is increased by 1, so this longer side we could call x plus 1. The other side was decreased by 2, so this is x minus 2. We're given the area of this new rectangle. We're told that that area is 180 square inches. And we know the math formula area equals length times width. So with that math formula, we can create our equation. Take the length, x plus 1, multiply by the width, x minus 2, and that's equal to the area of 180. Now we need to solve this equation using algebra techniques that we know. The only one we've recently studied is to have a 0 on the right side in factored form on the left. Well, we have factored form, but we don't have a 0. So we need to subtract the 180. But at the same time, we're going to need to multiply out this binomial so we can later combine our constant terms. X times x is x squared. X times negative 2 is negative 2x. 1 times x is positive 1x. And 1 times negative 2 is negative 2. And let's also subtract the 180 away so that we have equals 0. Now recombine the terms. X squared minus 1x minus 182 is equal to 0. Now let's factor this trinomial using FOIL. X times x is the x squared. We need two numbers that multiply to negative 182, so one of them's positive and one of them's negative. And we need the two numbers to have a difference of just 1 unit. With the help of a calculator, I see that 13 times 14 is 182. So let's go with negative 14 and positive 13. Now set each one of these factors equal to 0. And solve them. This is x equals 14 or x equals negative 13. We're not done. We need to check these results against the original problem. Find the length of a side of a square. Can the side of the square be positive 14? Yes, it can. Lengths can be positive numbers. But the length cannot be negative 13 because that doesn't make any sense. How can the side of a square be negative 13 inches? So our answer is 14 inches. Number 5. A missile is fired from ground level with an upward velocity of 6,400 feet per second. When will it return to the ground? So the word when is asking us, in how much time will it return to the ground? And it gives us the suggestion of looking at example 3 in the book. That example is on page 141. The reason that we need the example is to find the physics formula that involves the velocity of an object that is shot upwards and then returns to the ground due to gravity. Here's a quick sketch of the situation. If this is the ground, and this is a missile launcher, and a missile is fired upwards in this direction, gravity will cause it to slow down and eventually fall back to the earth. From the side, the shape of that trajectory is called a parabola. The math formula that we need is h equals r times t minus 16t squared plus k, where the letter h represents the height of the missile at any time put in for t, and the letter k represents the initial height of the missile. We want to know how much time goes by when the missile has returned to the ground. So when the height has returned to a height of 0, what is the answer for t? For the rate, fill in 6,400. And for the letter k, the initial height of the missile, fill in 0 because the missile was fired from ground level. Here's our equation. Let's put it in a format that we know how to solve. We have the negative 16t squared plus 6,400t is equal to 0. Let's factor the left side. We can take out negative 16t as the greatest common factor. Negative 16t times t is the negative 16t squared, and negative 16t times negative 400 is the 6,400t. Take each factor and set it equal to 0. Now solve each. Dividing both sides by negative 16, we get t equals 0. Over here, adding 400, we get t equals 400. T is time, and the unit of time mentioned in the problem was the word seconds, so our numbers are in seconds. Now, which of them makes sense? When we fire the missile, will it return to the ground in 0 seconds, or will it return to the ground in 400 seconds? It's the 400 seconds that makes sense. The other answer is simply saying that the missile is on the ground if you never fire it. Number 7, the base of a triangle is 2 feet greater in length than its altitude. If the area of the triangle is 40 square feet, find the lengths of the base and altitude. This discusses a triangle, so let's draw a picture of a triangle. I'm not trying to draw it to scale, I just want to have a diagram to help me visualize. We're told that the base is 2 greater than the altitude. Let's draw a dashed line from the top straight down to the bottom, touching at a 90-degree angle. That is our altitude. If we call the altitude x, and the base is 2 feet greater than the altitude, then the base is x plus 2. The other thing we're told is that the area of the triangle is 40 square feet. We need the formula for area of a triangle. Area equals 1/2 base times height. Let's make our substitutions. For the base, fill in x plus 2. For the height, also called altitude, fill in x. And that's equal to the area, 40. Now simplify the left side. 1/2 times x is 1/2 x squared. And 1/2 times 2 times x is positive 1x. Now I'm going to multiply all terms by 2 to remove the fraction. I don't have to do that, but I'm more comfortable when I don't have any fractions in the problem. Now let's subtract 80 from both sides to get it equal to 0. And factor. X times x is the x squared. We need two numbers that multiply to negative 80, so one of them's positive and one of them's negative. And we want the difference of the numbers to be only 2 units. How about going with an 8 and a 10? So positive 10 times negative 8. Now set each factor equal to 0. And solve them. Now let's check these answers into the original problem. The letter x was representing the height of a triangle. Can that height be negative 10? No, that doesn't make any sense. Heights cannot be negative numbers. But it can be an 8. And so our answer for the height, also called altitude, is 8 feet. But we were also asked for the length of the base. And so the base is x plus 2, or 8 plus 2, which is 10 feet. It's really important you take your answers and check them against the context of the question, or else it's likely we would forget to find the altitude and the base. Number 13, a rectangular lawn is 40 feet by 60 feet, and the grass is cut in a uniform strip along the edges, so that 1/3 of the grass remains uncut. How wide is the strip? Let's draw a diagram to help us visualize this situation. Here is our rectangular shaped lawn. We're told that that is 40 feet wide and 60 feet long. Then a strip of grass is cut along the edge, all the way around. So here in this border, this grass has been cut shorter. And in the middle of the yard, the grass has been left longer. There is a rectangle inside of the other rectangle. And what we're asked is, how wide is the strip? So we could call that width x, going from there to there. And similarly, it's x, going from there to there. we can label the length and width of that inner rectangle. This is 60 minus 2x, because we're subtracting this x and over here another x. And this height here is 40 minus 2x, because it's 40 all the way across, but we would be subtracting this x and this x from those strips. We're told that 1/3 of the grass remains uncut. So the area of the inner rectangle is 1/3 of the original area. Let's make an equation for this. We know the formula for area of a rectangle is area equals length times width. Let's take the length of the inner rectangle and multiply it by the width of the inner rectangle, and set it equal to the known area of that inner rectangle. We are told that that is 1/3 of the original area. The original area would be 60 times 40, or 2,400. Now let's multiply the left side together with FOIL. 60 times 40 is 2,400. 60 times negative 2x is negative 120x. Negative 2x times 40 is negative 80x. And negative 2x times negative 2x is positive 4x squared. 1/3 of the 60 times 40 is 1/3 of 2,400. That's 800. Now let's combine like terms on the left side and subtract the 800 in order to get a 0. We have 4x squared minus 200x, and then the 2,400 minus 800 is 1,600, and that's equal to 0. This trinomial has a greatest common factor of 4, so let's factor that out the front. And then factor the remaining trinomial using FOIL. X times x is the x squared, and we need two numbers that multiply to positive 400. Looking in the middle, I see the sum of them is negative 50, so they both have to be negative numbers. And they have to add up to 50. How about going with 40 times 10 makes 400? Now take each variable factor and set it equal to 0. And solve each of these linear equations. X equals 40 or x equals 10. Let's check the result against the original question. First of all, what was the letter x? It was how wide the strip is. Could the strip be 40 feet wide? That doesn't make any sense at all. The entire yard is only 40 feet. So how can just the strip here be 40 feet? Could the strip be 10? Yep, that makes more sense. So our answer is 10 feet. Number 15, in the circle at the left, we're given these measurements. Let's label them. So from C to D is 14. So this entire segment all the way across is 14. From A to E is 3. So this little piece here is 3. And from E to B is 16. So going from here across to here, label 16. Find CE and find ED. We want to find this piece and this piece. Notice we know that they add up to the 14 that we had labeled for all the way across. To help us, we're given this geometry theorem about intersecting chords in a circle. The AE part times the EB part is equal to the CE part times the ED part. Let's make our substitutions. AE is 3. EB is 16. CE we don't know, and ED we don't know. But what we do know about them is that they add up to 14. So let's use a variable x on this one, and then we would know the other one would be 14 minus x. Now let's solve this equation. 3 times 16 is 48. X times 14 is 14x. X times negative x is negative x squared. Let's put all the terms on the left side so that we have 0 on the right. Add x squared to both sides. We get x squared plus 48 equals 14x. Now subtract 14 from both sides. We get x squared minus 14x plus 48 equals 0. Now factor this trinomial. X times x is the x squared, and we need two numbers that multiply to 48. Because the middle term is negative, they both have to be negative. And we want them to add together to 14. So how about going with 8 and 6? Now set each factor equal to 0. And solve them. Remember, what we were looking for is how long is it from C to E and from E to D, and we knew that they added to 14. So there are two possibilities. If that first part from C to E is 8, then its corresponding part from E to D would be 6. Or it could go the other way. From C to E could be the 6, and then its corresponding part could be the 8. Either way, it adds up to the 14. For the review assignment, we're going back to page 142, where we had these same kind of equations, we just didn't have any word problems with them. So we want to make sure there's a 0 on the right, and we want to factor the left. Let's factor the trinomial using FOIL. X times x is x squared, and negative 8 times negative 1 is the positive 8. Now solve for x. We get x equals 8, or, and then over here, x equals 1. Number 4, let's factor this one. R times r is the r squared, and we need two numbers that multiply to negative 54. So one of them's positive and one of them's negative. We want the difference of the numbers to be a 3. How about going with 9 times 6? That makes 54, and the difference between 9 and 6 is 3. So positive 9 times negative 6. Now solve for r. This one here would be r equals negative 9. And this one here would be r equals positive 6. Number 6, let's factor the left side. X times x plus 4. This answer for x would be x equals 0. And this one would be x equals negative 4. Number 8, let's factor that perfect square trinomial. One set of parentheses squared. And to find these pieces, you take the square root of n squared, which is n. You take the square root of 16, which is 4. And because the middle term is positive, you put a positive there. This really means n plus 4 times n plus 4. So when you solve for n, you're going to get the same result either time. We would get n equals negative 4. Number 10, let's factor this. We can factor out a 2, leaving x squared minus 1. But this is a difference of squares, and it factors farther. As x plus 1 times x minus 1. The answer for x in here is negative 1. And the answer for x over there is positive 1. Number 12, let's rearrange it so there's a 0 on one side. I'm going to subtract 4y from both sides. We get 6y squared minus 4y is equal to 0. Notice I've also used the symmetric property to get the 0 to be on the right side. Now let's factor it. Both 6 and 4 divide by 2, and there's a y that divides into both of them. 2y times 3y is the 6y squared, and 2y times negative 2 is the negative 4y. The answer for this will be y equals 0. And the answer for this one will be y equals 2/3. What I'm doing is adding the 2 to the other side and then dividing by the 3.